Hello and welcome to the task Reflected Chopper. This task is part of environment mapping team, which is not covered in the lectures. You can read about this yourself from the basic 2 materials. So under here environmental mapping, it covers many different topics such as cube maps or sphere maps. And this time we are going to do one reflection, not the whole environment. So what we want to do in this task is turn the bottom floor of the hangar into a reflective surface, so we can see the reflection of the scene on the floor of the hangar. So if I go to the example images, you can see that there's a faint reflection here. For example, the chopper body, you can see it from the bottom, while the real chopper is, you can see it from the top. And here is the pure reflection, no other scene. And how we do it is we have 2 different materials and we render the same chopper twice. Once on the reflection, and then we store this reflection into a storage texture and then sample that storage texture here. So we have to calculate the UV coordinate of each fragment here and sample that texture to get the image onto the floor. And how we do it is we set up 2 cameras. The first camera is the regular camera. We see everything regularly. So that's the regular scene that we have already seen in the chopper tasks. But now we also have a reflected camera. And reflected camera is only there to see the scene from the reflected point of view. So you can see that if the camera's ray goes to this look at point, then the reflection is the you take the normal of the floor and reflect it from the normal. So the ray continues here. But this is equivalent to a ray that is coming from a camera that is just reflected from the floor itself. So we have reflected the camera to the other side of the floor. So for example, if the camera is 10 units above the floor, then this camera, the reflected camera, will be 10 units below the floor. Also the up is flipped. And then this reflected camera should render this reflected scene. One thing to keep in mind is that the specular highlight will be different. So you can see that there are 2 different fragments, 2 different rays to the fragments. You can see that if it's like this above arrow, then the specular highlight will be here. But from the reflected point of view, it will be below this. So the specular highlight should be in the different position in the reflected scene. You can see it here as well. For example, this very faint specular highlight can be seen just on the boundary of the floor and the wall. But here the specular highlight is smack in the middle of the wall. So you have to keep that in mind, and if the specular highlight is not in the correct position, then you have to change something. Overall, we are going to implement this article's implementation of the reflective surfaces. So this is much more generalized. It will work on any plane. So it has this reflection matrix. And you can read this if you want to change some other surface into a mirror, because currently the hangar floor is just a perfectly flat surface that is perpendicular to the y-axis. And yeah, here gives the GLSL code as well. And there's a final picture. You can see that the water has turned reflective. Here we see more mathematics, what we have to do. And now let's look at the codes or download the codes. The default state should look something like this. So the code is here. And in this code, we have 7 files. In the main, we set up the cameras and uniforms. Then we have a scene and utils. So the scene and utils just basically contain the code that was usually in the main. So for example, scene has the create hangar and create chopper. So, and also create wall and create cube and create sphere. And we also have a utils which has this millicent to rad. So usually they were in the main JavaScript file, but now they are just in the separate JavaScript modules. And we also have 3 shaders. So we have one vertex shader, It's just a regular vertex shader that should look very similar to what we have had before. So we have to have this interpolated position and interpolated normal. And then we have two fragment shaders. So the first fragment shader is just for the regular scene. So that's the regular chopper, the regular walls, everything like that. So that should look exactly the same as we have seen in the previous chopper tasks. And you should add the Phong or plane here. But we also have the Phong reflect fragment shader. And this shader will do something differently. It will render the bottom floor. So we have to sample this texture that we found in the reflected scene and sample it here. So then take the screen UV, calculate from the GLFAC chord, and then we have to also mix it with the regular reflectance. So it's not a perfect reflection, it has this tint to it. And yeah, so let's get started. Let's go through the main file. So we have this show light, which is true. So if I go here, you can see this red cube going around. So that red cube follows the light trajectory just for debugging. If you don't want to see it, you just set it to false. And now it doesn't exist. But currently let's set it to true because we want to actually see it. Then we have our renderer scene, but we also have the camera and the reflection camera. So those are the two different cameras. One is the regular camera, and then this is for the reflected scene. And then we have a chopper, we have a shaders. So vertex shader and fragment shader, and then we also have a Phong vertex shader and Phong fragment shader, Phong reflective fragment shader. I don't think these are used actually, so we can remove them. We also have floor reflection texture, floor reflective material, and floor. So this is the handling for the floor, because floor is different. We handle floor differently than the regular scene. Then we have a look at location, because we want to change it later. And then we use the light point light. So we have a light position, light trajectory, and the light itself. So this is the mesh, the light. Light is this red cube that is going around. And then we have a viewer position. In the load function, we set up the width and height of the canvas, and then we load the shaders. So we have 3 shaders. We do 3 loads. Then we are setting up the renderer and setting up a scene, and then we have this first camera. So we have this perspective camera, and here we're setting the position to viewer position X, Y, and Z. So what's on the viewer position Y? It's 0. So just keep that in mind. And then we want to set up the reflection camera. So let's do it right now. So where should the reflection camera be? So we have to take into account the position of the floor. So let's go to the scene and see where the floor is. So in the floor, so the position is -10. So that would mean that if the camera is at the position 0 and the floor is at position -10, we want to go the same distance down further. So we should go by -10 further. So that should be like -20. So let's just do this. So let's change the position, and instead of using this Y, we set it to -20. So this is just temporary. You should actually take into account the position here itself. So if I change this to -20 or -5, then this code should still work. So try to solve it like that. But currently it is -20, and since we are not changing the floor distance, we can keep it at -20. Then the up vector should be the opposite as well. So we have 0, 1, 0, just be 0, -1, 0. So that will be the reflected up vector. And the look at vector will be, well, look at position will be exactly the same. So that's why we are having it as a global variable. We will change it later as well. Yes, so those should be here. Yes. So that task should be done. Let's see what is more here. So now we have floor reflection texture. So this is the render target. That's where we render the reflected scene. This will be the same width and height. We have this minification and magnification filter set to linear and nearest, and the format is RGB. So should be actually RGB RGA format because RPG format is not supported. Okay, for debugging purpose, you might want to render a light source as a red cube. So yeah, this is the code for showing the red cube. And if you set the show light to false, then it's not shown. Add the hanger and the chopper. So this is where we add the hanger and the chopper to the scene. And chopper is a global variable, so we save it into a global variable as well. So we can see the hanger scene. That's where we imported it from the scene.js. So I gave it the namespace hanger scene or module name. You can get the objects from the scene by name. You have named them. So we want to save the floor because we use it later. So floor, let's create a reflective material for a floor. So this is the create reflective shader material. We'll see later what should be there. And then we just overwrite this floors material to this reflective material. And this add this line after you have specified the shader uniforms. So we first should specify the shader uniforms before we do that task. And we'll see how to do it soon. Then we have this event listener. And if we use arrow up, then we swap the cameras. So we can see in this, we have the regular camera mode, and then we have this. So this is camera up should, so arrow up should change between these views. So one is just a regular scene plus this reflection, and the other is just a reflection. Then we have arrow right and arrow left, and that's if we change the arrow right and arrow left, we change look at, and that should change the look at position from this to this, and this is for testing the reflections. We can see if the reflection is correct at all the look at locations. So you should implement this later. And in the draw function, let's look at the draw function last, but first let's just create this shaders or shader materials. So send uniforms to the shader. This is the same as before, light position and color. So let's implement these first. So light position, and light position is the vector3 type. So it will be v3, and value will be the light position global variable. So this was easy. We have seen it before, and the color is the same. Actually, you can copy paste it basically. Instead of using the light position, we use color, and v3 instead we use c, and this is the argument for the function. So you can do that. So this was for the regular func material, but now we have to do the same for the reflective material as well. So let's keep both light position and color as well. But now instead we also had to add the reflection texture, and we can do that here. Reflection. So that's not texture, that's camera. So texture, and this will be this will be type texture. So T. And the value will be the rendering target that we saw, that we defined. So we have this, where is it? Floor reflection texture. So this is a rendering target. That's where we rendered the reflection. We want to use it in this shader, so this will be here. But now we also have to set the texture attribute of this. Instead of giving it the rendering target, we should give it the texture itself. Okay, so those three are given. There will be one more thing. Actually, we should also give it the screen width and height. So this is a screen. This will become useful later when we want to calculate the UV coordinates to sample this texture in this scene. So it will be type v2. And the value will be new 3 vector 2. And the values will be the width and height. And if you noticed, those are actually not global variables, so we should change that as well. In the onloads, those are the first two variables, or second and third variable we define. Let's just convert them into global variables so we can use them. So now we have 3 or 4 uniforms here, and we can do the task that we saw. So floor material uniforms reflection texture value, and this will be this reflection for texture, and that should also be the texture. Okay. Let's see if I made any errors. So F12 and no errors so far. So everything should be all right now. Let's look at the draw function now. So in the draw function, we are changing the light trajectory, and then we are rotating the blades, and then we change the chopper position as well. So that's what we see here. But now we have these 2 rendering passes. So first pass, we render the reflection camera into the storage texture. First, we need to find out the light's position in our reflected camera space and set it for all objects that use our shader. So we use this traverse function again, and now we set the light position, but we want this light position to be in camera space. So let's comment this in. So object material uniforms light position value now will equal, actually let's copy it, because this is already the vector that we want. So we don't have to create a new vector. So what we want to copy here is the light position, the global variable, but now we have to apply matrix 4 and use the camera. So this will be the reflection camera. And we see here that we have to use the matrix word inverse. So let's get this matrix. Oh, then we apply this matrix onto the light position, and then we should get this light position in the camera space where the camera is the reflection camera. And that's what we wanted. So let's change the position here. So that's what we did. We took the object, changed its uniform light position value to the light position in the camera space, and the camera will be the reflected camera. So now we disable the floor, because in the reflection we don't actually see the floor, because the floor is the reflection itself. And then we render it. So we set the render target to the floor reflection texture. Then we reflect it using the scene and the reflection camera, and then we set the render target to 0 again, and that will use the default render target, which will be used in the pass number 2. And this is where we render with the main camera. So enable the floor. So we want to enable the floor again, but remember the floor has this reflection material now. Okay, so we need to recalculate the light's position again. This time it should be the main camera space. So let's just repeat this. So I'll copy, I'll paste. Let's indent it in the correct position. Oh, this is not in the correct position. So here. And instead of using the reflection camera, we use the regular camera. And now we render it again with just the regular camera. And let's see if there are any errors. So no errors so far. But we might start seeing them soon when we change the shaders. And I think that's the next thing we should do. We should change the shaders. So let's start with the vertex shader. We want these interpolated position and interpolated normal to get the lighting. So interpolated position, this will be the position, but we want this to be in the world space, or the view, camera space rather, because model space turns it into world space, and from the world space we want to go into camera space, which is the view matrix. So let's multiply this. But yeah, position is this thing. And then we want only the first 3 elements. So X, Y, Z. So that should be the interpolated position. And now we want to use the same thing, but for normals. So interpolated normal. And this will equal the normal matrix, and we just give it a normal. We don't need to transform it into a fine space. And now we should get these values in our shader. So let's calculate, well, let's implement this first. So we have the light position, we have color, and now we have this interpolated position, interpolated normal, and in the end we should get the regular scene values here correctly. So no reflection, but regular scene will be visible. So I changed the console location to here. We can see the whole canvas now. Okay, so find N, L, V, and R. So those are the regular vectors that we used in our Phong lighting model. So the N will be from the interpolated normal. So we have to normalize it. Then we have L, which is the direction towards the light, and normalized again. So this will be the viewer, no, not viewer position, the interpolated position, because this will be the vector from the position to the light. So, and this is the light position. Then we have V, which is the direction towards the viewer from the position. So this will be the, oh, I think this is the other way around. So we define it exactly the same as the L, but instead of using the light position, we use the viewer position. And viewer position is defined here as just a 0, because our camera, in the camera space, the viewer will always be in the center of the world. And we use the interpolated position again, because we want this vector to be from interpolated position to viewer position. We want this to be in that direction, and we normalize it. And finally, we have R, which is the reflect. And what we do is we use the GLSL reflect function. And firstly, we set the incidence vector. So this will be the L minus L. So this is the vector from light to the position. And then we set the normal. And this is the N. So now we have all the components for the Phong or Plin lighting model. Well, Plin also has this halfway vector, but doesn't matter. So let's calculate the color for this now. And let's do it very simply as let's add the diffuse lighting. So this will be 0.2. And then we also have to add the, oh, this is the, not diffuse color, sorry, this is the ambient color, 0.2. And now we had to add the diffuse color. So this will be, actually let's let this be a float. And because we want to multiply this with the color, right? So color, and the color is the vec3, so vec3 times float is vec3, so that's what we want. So now we have to add this diffuse component, and we want this to be this dot product, remember? And the dot product between normal and the light direction. And this should be the Phong lighting model without specular highlight. So let's see. And yep, I can see the chopper. It has this brighter spot and it has shadows. So this is actually what we wanted to do. So you should also add the specular highlight as well. So this is only halfway done. But let's see what we have to do here. So let's copy what we did here and paste it here. So let's make more room. Oh yeah, so this should be done after these things. Okay, so then use the screen UV. So I have to calculate the screen UV. So how to do that? So let's calculate the screen UV. Screen UV. And it says I should use the GL frag chord, so I'll use it. I'll use the first two, so X and Y. I don't care about depth. And now I should divide it by the screen. So this is the screen frag chord xy, I divided by the screen width and height. So that's why I added this uniform. So this is the vec2 screen. So this should be the screen UV, and I should sample the reflection texture with this. So let's sample it. So it's vec3 reflect color, and I use the texture 2D, and the texture will be the reflection texture, and the screen UV will be the UV coordinates. So if I set it here, what do I see? I see error. So fragment shader is not compiled, dimension mismatch. Let's see, where is the dimension? Oh, this is the reflection color. This is because it has to be the RGB. And color redefined, of course, because the color is the uniform, right? So this should be not color, it should be the result color. Or anything else you could think about. So yeah, now I have a reflection here, but this is a perfect reflection. So I should actually mix it. So reflect color and the color itself. So this is the color. Should actually rename this because the color and color, those are the same. So this should be light color, perhaps. Just to not be confusing. So let's set it to 0.5 for now. And now it's a bit dimmer because it uses the color from the lighting calculations as well. So if I change it to 0.2, for example, then it's more perfect, but for 0.8, for example, it's more dimmer. So you should also add the specular highlight to see if the specular highlight is in different places. And one more thing you could maybe see here is that the blades go in the opposite directions. So you should fix that as well. In fact, if I go 0.0, you can see that the lighting on this wall is actually the lighting here. So it's the reflection is flipped. So it's for you to figure out how to fix this. You can also see maybe the reflection here in the back wall. Is this also the does it truly reflect this wall? So you should check it and make sure it reflects the correct things. And if you also implement the key down events, so swapping the camera and the change look at functionality, then the task should be complete for you. So I'll let you figure out how to fix this, also add the specular highlight, and good luck for solving this task.